I always start by looking for a diameter. And when I'm looking here, I see two diameters. I see that this one is a diameter because it goes edge to edge and through the center. And so is this one. So that can help us fill in some of the missing pieces. So is there any side that you see that you can fill in right away? Oh, I see some vertical angles. Do you all see the vertical angle? Okay, so if this side is 53, that means we could put a 53 right here. So let's go ahead and put our 53 right here. That's a good start. Let's see, anything else we could fill in? Okay, so because I have my red diameter, I'm gonna take off this diameter. Do you all notice that this half is equal to 180? These three slices equal 180. And I know two of the slices. So how could I find this last piece right here? If I know that if I were to add, if you add this plus this plus this, it equals 180. Okay, everybody with me so far? Okay, so these three slices equal 180. So how can you figure out what this slice to, what does that equal? What would I have to do? Add 85 and 53, and then do what with that number? Subtract it from 180. Go ahead and do that. And what did you all get? 42? Is that what you all said? Who got 42? Okay. All right, so that's good. So the only slice we have left is on this side, is this piece. But that's on the other side of my diameter. So I know that 1 plus 2 equals 180. So you just need to subtract 53 from 180. And that's going to give you that last slice. And what did you all get? 127. Who got that? Okay, so now we can easily go ahead and find the arcs. So for this first one, it says you're going to start at T and go to U. So if I start at T, which is right here, and I go to U, that would just be this arc. And what is the measurement of that arc? 53. All right, I'm gonna give you 60 seconds to find the last two. Figure out from S to T, you're gonna have to add, and then from Q to U. Go ahead and find. So ST, you have to add two together, but QU, you don't. All right, Cortez, what did you get for ST? 95. Anybody else get 95? All right, so to go from S to T, we would have to add 42 plus 53, because this is S to T. So that's two slices of pizza. So when you add 42 plus 53, you get 95. All right, Alan, what did you get for QU? 127. So QU goes from here to here. And from here to here is 127. All right, any questions about our bell work? Let's go to our note packet. We're going to learn about inscribed angles today. So we started with central angles. Central angles have a vertex at the center. And now we're talking about inscribed angles. Inscribed angles have the vertex actually on the circle. So turn to page 13. Okay, so on page 13, this is what an inscribed angle is. So we have 3 points, but our 3 points they're all on the actual edges of the circle. Okay, so when you see something like this is 3 examples of inscribed angles. One of them does not have to go through the center. So this is an example where it goes through the center. And these 2 don't go through the center. But here's what you need to know about an inscribed angle. Whatever this angle is, and I'm going to call this X, the arc is double. Okay. So whatever this is, so let's just say, for example, let's just put a number. Let's say that this angle right here is 80 degrees. Then that would mean that this arc is double. It's 80 times 2, which would be 160. Okay. Again, this is my angle right here. So if I know that this part, let's say this part here is 50. That's my arc. Then the angle is half. And what's half of 50? 25. That's the main thing you have to keep in mind about an inscribed angle. Inscribed angles are always half. It's always half of the arc. And that's what this formula says here on page 13. So it says the measurement of angle 1, and this just says what I just said, but the measurement of this angle is half of the arc. Or you can say the arc is double the angle. All right, so let's do some practice. Oh, one more thing. If you have 2 angles that share an arc, and if you look here, the one I have here, they're in color. So I have 2 different angles. This is the arc. My arc is from A to D. But do you notice how both of these angles, even though the vertex is at different places, they both open up their arms. The arms of the angle are at the same spot. When that happens, whatever these 2 angles are, they're equal to each other. So let's do a couple practice questions. Let's go ahead and go to page 14. And let's do it. So let's look at page 14. So the first question is asking me for the measurement of this arc. Okay. This here, this is the angle where the arms, see how the arms are on the edge of the arc? And what's the measurement of this angle right here? What does it tell us the measurement of this angle is? 40. So that means the arc is going to be double that. So the measurement of arc CF is going to be 2 times, and I'm going to put the measure of angle CDF. And because the measure of angle CDF is 40, that means it's 2 times 40, or 80 degrees. All right, so the measurement of angle C. So here is my angle C. I'm going to go ahead and trace it. See how angle C goes from here to here. That's this angle. That's not the same as that 40-degree angle. But if we look at where the arms land right here at this arc. So I know the measurement of arc DF, or DE, sorry. So that means that the measurement of angle C is going to be 1/2 the measure of arc DE. It's 1/2 the measurement of arc DE. And what is the measurement of arc DE? 98. Go ahead in your calculator. You're just taking 98 divided by 2. No, I got you. There you go. Take 98 divided by 2, which is the same as saying 1/2 times 98. And 1/2 times 98, go ahead and type that in your calculator, Leslie, so you can get that. What's half of 98, or 98 divided by 2? 49. All right, any questions? So again, the main thing is an inscribed angle is half of the arc. That's what you need to remember. For central angles, they're the same, but inscribed is half. So now let's look at this example here on page 14. So this is what they want me to find. There's a lot of lines happening here, but don't get confused by that. What I want you to do is I'm going to trace this. And then it's like I'm trying to make my ice cream cone. So this is gonna go to this edge to this edge. So this is the angle. So there's a lot of marks in that diagram that we're not even using. So if I know that this is 44, this is my inscribed angle. What do I have to do with the 44 to figure out the measurement of that arc? Multiply it by what? By 2. Because the arc is always double the angle. So the measurement of arc XW equals 2 times the measure of angle XVW. This is a number, that's a number. So if I'm trying to figure out the measurement of arc XW, that is going to equal 2 times 44. And what's 2 times 44? 88. All right, I want you to take a minute and try to do this next one by yourself. You're trying to figure out the measurement of this angle. That's where my question mark is. I'm going to go ahead and trace it out. There's extra lines in there, but the extra lines don't matter. You have enough information. So I'm going to come around. I'm just going to look over your shoulder. Tell me if you can figure out what the measurement of that angle would be. So the arc is double. What you all get? What's the measurement of the angle? So I see some people say 200. So it's like 50-50. Either you multiply by 2 or you divide it by 2. But what should we do for this one? You should divide, okay? Because the angle is half of the arc. So it should be 1/2 times 100. So the correct answer is 50 degrees. That would be your right answer. Thumbs up if you have 50. All right, fix it in your notes because, again, this is just practice. We're just practicing for the test. Test is March, I think the 19th. It's a Tuesday. All right, let's go ahead and keep practicing here. So now we have 2 angles. So I'm going to trace this out. I know that this angle right here, I have this angle, and I have this angle. But do you notice how even though their vertexes are at different places, they share the same arc? So because they share the same arc, then you can go ahead and put a little mark here to show that they're congruent. They're equal to each other. So we're going to create an equation. I want you to take 5x minus 12 and set it equal to 3x plus 2. Go ahead and solve that for x. This is a 2-step equation, a 2-step problem. All right, take a minute and solve that for x. And this is my first period of integrated, so I don't know the answer. I'm just looking at yours to see what we get. Okay, let's see if anybody else get that number. Not bad. All right, most of you all got 7. Who got 7? All right, let's go through it together. So what did you do first? You added 12. All right, so let's go ahead and add the 12 to both sides. And then what are you going to do? So let's subtract the 3x. Go ahead and correct your work. If you didn't get it right, that's okay. Don't get discouraged. We're just practicing. It's not the test, it's practice. 2x equals 14. Because 5 minus 3 is 2. And then your last step would be to divide by 2. So you would get x equals 7. All right, but that's not my answer because that's not what they asked us to find. They want us to find the measurement of angle A. So the measure of angle A, you see how this little arrow, this is like pointing in here. So we need to substitute that 7 in this equation. Or this expression, sorry, it's not an equation. So the measure of angle A equals 5 times 7 minus 12. Go ahead, type that in your calculator. And then that would be your final answer. So that would be what? What did you get for your final answer? 23. Who got 23 degrees? Okay, good. That would be the measure of angle A. All right, let's do one more. Thank you for turning it off. You shouldn't even have your earbuds in, Cortez. Can you take your hood off? Okay. All right, so last one. I think it's on the same page because we're on page 15, right? All right, so let's go ahead and finish this out. So again, do you notice that we have these two angles? So let me trace it out. I have this angle and I have this angle. And what do they share? What do they both have? The same arc. Their arms hit the same place, so they have the same arc. So let's go ahead and start by setting these equal to each other. So I want everyone to practice. Take the 3x minus 5. Set that equal to 2x plus 15. All right, go ahead and solve that for x. And then you're going to put that answer back into this expression to get the measurement of angle T. So first step, find x. Second step, substitute. All right, so let me look around, see how we get what we get for x. So you wouldn't subtract the 5, you would add 5. So it's 15 minus 5. Okay, good. So subtract the 2x. All right, you all did real good with this one. So you subtracted 2x. So that would be 1x minus 5 equals 15. And then you add 5. And 15 plus 5 is 20. So who had x equals 20? All right, good. Now to find the measure of angle T, that would be 3 times 20 minus 5. And 3 times 20 minus 5 is 55 degrees. All right, so let's end there. On Friday, we'll pick up on this again. We have a couple more questions we'll do on Friday. Don't forget to check Canvas tomorrow for your e-learning assignment. And homework 2, I know I said that it was due on Friday, but it's actually, I'm going to push that back. But use this time now to keep working on homework 2. You should have the whole front side finished, and now you can start working on the back. I'm sorry? Okay, if you were absent yesterday, you want to go to the hanging folder for integrated. Yesterday was Tuesday, so any handouts would be in the Tuesday folder.